2.1.1 Graphs of piecewise functions. A piecewise function is defined as a function that uses different rules for different parts of its domain. So we've graphed piecewise functions before, and so we're just looking at them again. Of course, we want to graph these without our graphing calculator. And recall that the x value where the function changes, we're going to refer to that as our transition point. So in this case, if you look at this example, the transition point is at 3. All right, so let's go ahead and look at our first example. And again, we are going to graph these by hand. I will show you how to do them in the calculator, and you can follow along as I do them in calculator. You should do them as well. But again, that's just to check your answers, because some of these graphs might get a little bit more difficult. But again, on the test or quiz, we won't have a calculator, so make sure you know how to do these without. So looking at this first function that we have f of x is equal to x squared if our x values are less than or equal to 1, and f of x equals x plus 2 if the x values are between 1 and 4. So if I'm graphing this by hand, the first thing I'm going to do is go ahead and make an xy table. And I'm going to look at my transition point. So we have x values less than or equal to 1, and I'm always going to start at that value that we have at the transition point, so 1. So if I plug 1 into my quadratic function, 1 squared is 1. If I look at my transition point, we want x values less than or equal to 1, so the next value I'm going to use is 0. 0 squared is 0. Then I'm going to use negative 1. Negative 1 squared is 1. Negative 2 squared is 4, and negative 3 squared is 9. And we can go ahead and plot these. So we have a closed circle at 1, 1 because we're less than or equal to. And then we can plot our other values. And this is, of course, a quadratic function, so the shape makes this parabola, which is a U shape. Now we've done the first part, and we're going to go ahead to the next part. So for the next part, our second equation is linear, and we're looking at values in between 1 and 4. So I'm going to make, again, another xy table. And we're going to start with our first transition point of 1. So if I plug 1 into the function, 1 plus 2 is 3. If I plug in then 2, because again we want values that are above 1 but below 4, so 2 would be 4, 3, 5, and my upper transition point, which is the 4, 4 plus 2 is 6. So for our first part of our transition point, x is greater than 1, so there is no equal there, which means we have an open circle at the point 1, 3. And then we have 2, 4, and then 3, 5, and 4, 6 is closed because it's less than or equal to. And you would use your ruler to draw the straight line. So this is the graph of my piecewise function. And we could also look at the domain and range of this function. So our domain, we can see we have x values less than 1, and then we have x values between 1 and 4, but because there's a closed circle here, we can include 1. So our domain is from negative infinity to 4 bracket, and then our range values start at a y value of 0, including 0 all the way up because this arrow to infinity, so bracket 0 to infinity, parenthesis. All right, so let's go ahead and look at this and check it using our graphing calculator. In our graphing calculator, when we plug this in, I'm going to show you two different ways. The first way is plugging the equations in separately in y1 and y2. And then notice that when we plug them in, our domain restrictions to get the inequality symbols, you can hit second math, which I'll show you. Also notice that for the second equation, that we have, notice that I wrote it separately and not all together, such as it is in the given function. So the reason you have to write it separately is that your calculator just gets confused when you try to write it together, so always make sure to separate it like I have here. So let's go to our calculator. You guys should practice along using your calculator. In our calculator, go to turn it on, go to your y equals, and in my y1, I'm going to plug this first equation. So parentheses x squared close parentheses, and then we're going to use the division symbol, parentheses, x, and then to get the inequality symbol, second math. And so you can see all these symbols right here. We want less than or equal to, which is number 6, and then 1, close parentheses. And then we're going to go into y2, and in y2 parentheses, we're doing our linear function, so x plus 2, close parentheses, division symbol, parenthesis, parenthesis, because again, we're writing it as I have over here, not as it is in the equation. So 1, second math. Now we want number 5, which is less than x, close parentheses, and then start a new set. And then x, second math, number 6, and then 4, close parentheses, twice. So now that I have that, I can go ahead and hit graph. And you can see that our graph looks like the one that we drew on our paper. The only difference is you can't really tell what the open and closed circles are, which is why it's important to know how to do this by hand. If you don't see this nice viewing window here, you can go ahead and hit zoom 6, which is a standard window. A standard window just means you're looking at x values from -10 to 10 and y values from -10 to 10. So it's nice to graph functions that you can easily see in this window. And now that I have that, I can go to second graph and look at my table of values. So in Y1, I'd be looking at the quadratic portion. So of course, notice that anything above 1 says error because we're looking at x values less than or equal to 1. So it only will show you values that are less than or equal to 1. And if you look at the second function, notice that we have values in between 1 and 4, but not including 1. So notice that 1, it has an error here, but we don't see, because I haven't changed my table set here, see the values in between 1 and 2. But notice above that, we do have all the other values except for once we get to 5, we have error because we only have values from 1 to 4. So if I want to see the values from 1 to 2, because they are there, I can go to second window, and right here it says table change is what that means. So I can maybe plug in 1, let's go by 0.1s. And if I go back, you can see, oops, I should have started my window at 1. So second window, we're going to start, our table start at 1, so I don't have to scroll through all those values. So now you can see, even though at 1 we have an error because it's an open circle, we have 1.1, 3.1, 1.2, 3.2. So if you didn't know that, this is open circle and these values are here, you might miss it. So that's why, again, it's good to know how to do this by hand. If I go to my graph again, I can even check by using second trace, which is going to be this first one, number 1, which is value. So it'll allow me to plug in x value. So if I plug in 1.1 just to show you graphically and hit enter, so notice that first it shows up using the y1 equation. So to get it to y2, because it's not going to have any y value at 1.1 for our first equation because it's only x values less than or equal to 1. So I hit the down arrow. Notice now it goes to y2 function, which is this part right here, which is the linear function. And notice it gives me 3.1, and I can do it again, second trace value. And if I do 1 point, let's say 5, and then again, I have to hit the down arrow to get to the second equation. Notice it gives me 3.5. So again, if you didn't do this by hand and you just use your calculator, you might miss those values if you didn't know, which is why we learned how to do this by hand. Another way you can plug this into your calculator is what I have written right here. So you can plug it in all together. Notice there is no division symbol here or here. And to write the equations together, we use the plus sign in between. So I'm going to go ahead and put that into my calculator just so you guys can see. So in my y equals, I'm going to clear out what we wrote for y2. Go up here and delete this division symbol. Do the plus sign. And then parentheses, my linear function, which is x plus 2, close parentheses, and then parenthesis, because now we're going to do the restrictions, which is from 1 to 4, so second math, number 5, x, close parenthesis, and then x, second math, number 6, so that's equal to 4. Just have to write them separately. And if I hit graph, you can see it also graphs it, but when you look at your table, Notice your table doesn't have a y1, y2 because we didn't plug in two functions. We just plugged the function into y1, which is why you don't see the two tables. And I'm going to actually go to my window and change this back to just 1. And if we look at our table, you can see that it will give you the values. So again, the only tricky part is knowing that right here, if you didn't know there was an open circle there, you might miss those values in between. I usually like to write it in as this two separate equations so that way I can look at y1 and y2 separately. But again, it's just a personal preference, so whatever you prefer is fine to check your answers with on your calculator. All right, so let's go ahead and do one more example. For this next example, we're going to go ahead and graph this again by hand. So looking at the first part, we have a linear function, and our transition point is at -1. So we're going to go ahead and make our table and plug in -1 first, because that's where our transition point is. When I plug in -1, -1 times 2 is -2 minus 3 is -5. And we know that is going to be an open circle because we're not equal to. Notice it's just x is less than -1. So at -1, -5, we would have an open circle. Then I'm going to plug in values that are less than -1. So -2. -2 times 2 is -4, minus 3 is -7. And then if I plug in -3 into my function, -3 times 2 is -6, minus 3 is -9. Again, that's linear, so it's just going to be a straight line. And so when you use your ruler, you connect dots to get your linear function. The next one we have is absolute value. So again, make our table. For this one, our first transition point is at -1. So we're going to start with that. -1, the absolute value of that is 1, minus 3 gives us -2. I want values in between -1 and 2. So I'm going to go ahead and use 0. When I plug 0 in, I would get -3. Then when I plug 1 in, I would get -2. And then if I plug in my upper transition point, which is 2, the absolute value of 2 is 2 minus 3 is -1. So now I can go ahead and graph my absolute value, which again, remember, makes a V shape. So -1, -2, we know is going to be a closed circle because both of these are less than or equal to signs. And then all I have to do is connect the points. And the next one that we're going to look at is our quadratic function, and our transition point is 2, so we're going to go ahead and start there. And so for this, we want x values greater than 2, so when we plug in 2, 2 squared is 4, and again, it's not equal to, so that means it's going to be an open circle at 2, 4. And then we have values greater than 2. So if I plug in 3, 3 squared is 9. If I plugged in 4, 4 squared is 16, but we're not going to be able to graph that. So we have 3, 9. And remember, this is a quadratic function, so I don't want to draw a straight line. I'm going to try to curve it a little bit since it is quadratic. And that would be my graph. And if I wanted to graph this in my calculator to check, of course, you could plug it into y1, y2, y3, or you could use the plus signs like we did in the last one. So let's go ahead and look at the domain of this function. The domain, so if you look at your x values, we have x values less than -1, and then we have from -1 to 2, and since these are closed circles, it takes care of -1 and 2, and then 2 to infinity, so we end up taking care of all of our x values, so -infinity to infinity is our domain. And then for the range values, so the range values we have -infinity to 5 with an open circle. So parenthesis, union, and then notice it jumps up to -3 to -1, brackets, because we're including, and then union, and then we jump up to 4, not including 4, and going to infinity. So parenthesis, 4 to infinity. And that is my range for this function. And of course, the rest of your homework is to finish the rest of this packet, questions 2-1 through 2-6, and we'll take a look at it tomorrow.